Got another parametric one right here. There's all my working answers if you just need to check certain parts of this one. For part A is talking about the speed. You have a speed formula. It's just the square root of dx dt squared plus dy dt squared at 3. Now they give us the x. If I take the derivative, that's x prime, which is the same thing as dx dt. So that's how fast my x's are going. And then they already gave me the dy dt, how fast the y's are going. And so the speed, you just want to do x prime of 3. That means take the 3, plug it into that x prime equation right there, and then also take the 3, plug it into that dy dt, that y prime equation right there. So all I did was take the 3, plug into the first derivative for the x's, first derivative for the y's, did the square root of that, squared them, added them up, did the square root of that, and then got that answer right there. Now for part B, it's talking about the total distance traveled. Now total distance traveled, pretty sure when I made the videos over the original notes, over the parametric polar stuff there, the total distance travel was like our arc length formula. So the distance travel was the same thing as the arc length formula. It's just the integral of that speed formula right there. So you're going to integrate it between 0 and 4 of the dx dt squared plus a dy dt squared. So you got to plug that into the calculator, math 9 that thing, make sure you can get that number. And if not, please let me know. Part C, when it says a line tangent to the path is horizontal. Now, we know a horizontal tangent line, the slope is equal to 0. So if the slope of the line tangent to the graph, that's the dy dx is equal to 0 right there. All right. Now, so what we want to do is figure out if the direction is moving left or right. So we'll figure that out in a second there. But when it says horizontal, let's do that. So that means the dy dx is equal to 0. And we know on these parametric problems there, the formula for the dy dx is simply dy dt over dx dt. And so we have this fraction here, right? Well, remember a fraction is equal to 0, where the top, where the numerator is equal to 0. Now, that's technically also where the denominator is not equal to 0, so we're avoiding that 0 over 0 format. But my guess is that we don't have to worry about that on this kind of problem there. We're already kind of making it challenging enough for us there. So we're worried about a fraction is equal to 0, where the top is equal to 0. So I want to just figure out where that dy dt is equal to 0. They gave us the dy dt, so set that equal to 0. So you're going to graph that function and let that calculate the 0 for you. So graph it into the calculator in between the 0 and the 4, and then watch that graphing calculator video if you need a refresher on how to do that, but it'll calculate that 0 for you, and make sure you're able to find that number and practice that so you get your speed up and you'll get your comfortability level up with that. And then I just double checked. I plugged that into the dx dt, and I did not get 0 for that one, so I knew I was avoiding that 0 over 0 scenario. So that's for the first part. And then it says, is the direction of that motion going to the left or to the right at that time? Well, that means they're asking about the x. If your dx/dt is positive at that time, you're going to the right. If your dx/dt is negative at that time, you're going to the left, right? So left or right, you're just talking about that dx/dt. And so all I did was take that number, plug it into my first derivative for the x's, the dx/dt, the x prime. I got a positive 0.416 for that. So since you got a positive number, that means a particle is moving to the right, since that dx/dt or that x prime is positive at that particular point. Now, remember how they grade this stuff too. Let's say you made a mistake on the first part of part C, and you got like t equals 14 or something different. Okay, let's say you just got or you got like t is like 1.7 in between one. And let's say that when you plugged in that x equals 1.7, you got like a negative number, and then you're interpreting that their particle is moving to the left. You would have gotten full credit. Like if you happen to got the wrong number here, but you did this work right, and you plugged in that wrong number and got a negative answer and said the particle was moving to the left, you would have gotten full credit for this part of it. You would have just messed up that part and not gotten full credit for that. So as long as you're showing them that you know that property, so even if you're not sure how to do something, if you know how to do another part of that, make sure you show them how to do that property right there, and then you'll get credit for that. So it's kind of like some nice fair scoring on these things there. All right, now for part D, there's 3 parts of this, which is a little bit weird, but it's okay. So they're talking about the x coordinate is 5. All right, and so that means this x is equal to 5. And then we're going to find the following, right? Find the 2 values of which that occurs. So if the x is equal to 5, that means I'm going to take the 5, plug it in place for my x right there. This is x equals that stuff. So all I did was set that equation equal to 5. We had a real easy algebra thing, factor that, solve that, and find those 2 values. They said they're going to get 2 answers there, and we found those 2 answers there. So that first part is pretty easy. And then also the second part is pretty straightforward as well. We want the slope of the line tangent to the path at a point. If you want the slope is always the dy dx, and the dy dx is dy dt over dx dt. So I'm going to find the dy dt over dx dt at t equals 1 and t equals 3. And when I'm plugging into the dy dt, I'm using that guy. When I'm plugging into the dx dt, I'm using that guy. And then it's just some numbers that you're getting from there. All right, now the last part of that might be where you have some questions on there. You want to know what the y coordinate is, given that y at t equals 2 is equal to this. Now, it was a little tricky if you think about because you have these two different ones there. So are you going to find the y coordinate? Which one are you going to start with? What you're going to use? So here's my mindset there. We have a couple different numbers there, the 1 and the 3, but they tell me at t equals 2, this is our position. So if you already know where you're at 2, and then you got these numbers in questions 1, 3, you kind of just skipped over that 1 right there, and you're just going to go to 3. And so you want the y coordinate of that point. So they told us what the position was at 2. So you want to know what y is 3 is, because you already bypassed that 1. And so if they told you where you're at 2, you always got to take into account the initial position. So if I want to know what that y value is at 3 now, take into account your initial position at 2, and then pick it up where you left off, go from 2, and then go to where you want to go. So this is where you started, where you know where you're at t equals 2. And when you integrate the dy dt, it tells you where your y what your y position is going to be, where it moved in between the 2 and the 3. And then so you're going to math 9 that thing, all right? Because if I had to integrate this normally, I'm going to have to use integration by parts right there, which isn't difficult to do, but I got to remember I'm on the calculator part of the test, which means I can just math 9 that integral. It tells me where you win. And then when you take into account that initial position where you started with, then you're going to get that 4 answer right there. Recliner, rocking chair.